So we had a file. Or who wants to share what are some of the stuff that we did yesterday? Create database. What else? Drop in databases. Creating tables. Adding information. How do we add information? Maybe somebody in the back. Insert statements. So let's look at what we had here yesterday. This one. So we had two tables. Let me change this and we had two tables in a database that we call Pursuit. Those tables were classes and fellows. We saw that when we tried to add a fellow to a class that didn't exist, then Postgres will complain saying, or it will complain because we said that the table, the fellows table, has a class ID column that references the class's ID column. That is, if the class's table with the ID column doesn't have a record or a row in that column that matches whatever we are trying to insert, then it's going to fail. Right? Or in other words, we need to have a class before we can add a fellow, because a fellow must belong to a class. Right? So we saw that the references is a constraint that will prevent us from adding information if we don't have the right reference. We talked about some of the data types, serial, varchar, and we talked about some other constraints like unique for ensuring that a data or a row that we insert in this database contains a value that must be unique. So you can try, for instance, trying to add a fellow with the same email, and then this constraint will raise an error saying that column must be unique, something like that. Cool. So we saw how to insert in this fashion. Remember that for inserting, once you specify right after the table name, you will specify the columns that you want to insert to. On parentheses, comma separated list. Then after that, there is a values statement that is actually part of the insert too. That's why it's sort of like nested here a little bit. And then here, John will be the first name, Snow the last name, 500 the age, John Snow at winterfell.com, the email, and class ID 1. If you want to insert another record to this table, you could copy and paste this, right, and then change the values. Or you could just also do comma here at the end. You could have sort of like one insert, or in other words, one insert can insert more than one row. That is if we specify a comma here. I like to do it this way. Let's add, what's another character, Ben Stark. Let's say he was the youngest, so let's say like 18. B Stark at Winterfell. Let's say he belongs to the exact same class. We can do something like this. Let's see if I have something that is sort of auto-formatting MySQL, and it puts it here. But as I said, I like it more like this, a line like that. Cool. So once we have this, then let's execute it. How do we execute a SQL file? Aranza? PSQL hyphen or dash f name of the file seed.sql. Yes.
So you need single quotes, not double quotes.
Yes, for strings in for what we call strings in JavaScript, you will need single quotes. Yes. Yes, but what we call strings in JavaScript in Postgres, we need to have single quotes. SQL. So let's run this. Cool. Seems like everything went well. We don't see any errors, and we have insert 2. So this is saying it inserted 2 rows to the fellows table. So this is how you can insert multiple values. Cool. So questions about the inserting. Yes.
Why did you start with 2 and under the classes insert? So I'm sorry, that's room number. Never
Yes, that's correct. Room number. Also, what do you think will happen if I don't include the class ID for Ben Stark? Let me disable this thing. Never mind. What if I skip or remove the class ID from the second insert and tell us what you see, or check with your partner, whoever you're sitting next to. Where's everybody else?
I speak with Casper on a daily basis. I don't have any messages.
Oh, okay. Makes sense. What do you see? Yes, could you repeat that a little bit louder one more time? Did everybody hear? Like, oh, and what did Aranza say? That was very well said, yes.
What I said was that on top it says class ID. So, well, it says error and it has more target columns and expressions. What that's trying to tell us is that we have up there class ID, so it's expecting a value for class ID. So that's why we're receiving an error.
Right, thank you. Yes, that is why we're receiving that error. You could think of this sort of as a function that is expecting an input, and if you don't provide that input, then it doesn't like it. Right? So that's that. Let's see. Cool. So let's see now how to update a record. Let's do update fellows set So update fails. Let's say I want to change the age of Jon Snow from 500 years to 50 because I made a mistake. So we can do set age equal to 50, where, and I need to say that we're gonna get why we need to say where, let's say where first name, we could also do it by ID, first name equal John. And that was broken down that something like this. You could also write it in one line. Sorry.
Much like the other stuff, right? The formatting doesn't change.
Yeah, it's just because I have.
No, this is easy to read. I just didn't know if it goes
So this is how we can update the age of Jon Snow. If we run that file and we then go and inspect the age of Jon Snow, it should now be 50 instead of 500. So let's do PSQL, connect to pursuit. Then I'm going to select, let's do select name and age from, oh, I think it's first name, right? First name, age, from fellows. Now we see that John has 50 years instead of the 50. So why do you think, well, first of all, was everyone able to see the update? Oh. Update 1, yeah, it said, when I executed it, it said update 1. Maybe, Suzette, maybe you had an error on your SQL, maybe a spelling error, or... Yep. So
Well, the same thing happened to me.
cool. So why do you think we need where? Where did we see where before? Yes, and what kind of statement were we, or why were we using where? Like an if statement, a condition, right? Let's say we wanted to select all the countries from world or continent equal Europe, right? So here it's similar in the sense that you need to specify what row do you want to affect with this update. Here I only want to affect the row with first name John, or I could identify that row with the ID, the first name, the last name, or any other of the other attributes. You could also think of SQL as this sort of for loop that is going to it has to check all the rows. So you can think of it as from here. In fact, if we forget the where in here, what is going to happen is going to update all the rows to be age 50. Because Postgres is looping over the records in that table and updating those. So, but now we do the where, then we have a condition. So before Postgres makes the update, it's going to check if the first name of that row is John. If it's not, it just moves to the next one. And then eventually it finds, well, we only have two rows, and this is the first one. But yes, we need the where clause. Otherwise, all the records will be updated, all the rows. And then the set is what columns do you want to update. You could update more than one. Let's say he wants to change his last name to Stark. Oh yes. This should end up squid from here. Actually, so that this prints the output, I'm just gonna write the select here. Select to name, first name, last name from users. Where, let's now grab it maybe by where first name is equal John. I'm just doing this here. For the lab, you're going to have some create table statements, right? One will create a database, some create the tables, and then you're going to manipulate, you're going to add data, update data in that database. For those, we want you to put it in the same file like this, sort of here, like select Jon Snow. And then my auto formatted just prints it like this. So what I want to do is update Jon Snow and get the result to see if it did update it. Mm-hmm. Cool. So being outside of PSQL, I'm just going to run PSQL-F seed.js. And then I got an error. It says relation users does not exist. Why is that, Bunil? No. Hupo. There's no user stable. Remember that another word for relation is table. There is no user stable. So here from fellows. That's what I meant. Let's try again. Cool. We see now that as this prints the result of the select, we have John with, oh, I should have selected the age too to see that the age was updated as well. Age now is 50, and his last name has changed to Stark. Cool. Then the last, or questions about the update. Cool. So let's look at the delete, and so that I can give you time for the lab. Let's delete. Oh, I should have had a semicolon here. Delete. What was the other? Ned? No. Ben? This is Rob? Oh yeah, which one is the youngest one? He died? I haven't gotten to that part. That's fine. That's fine, but who's the youngest one? I don't know if I'll ever finish it, so. Bran. No, this is the one that I meant. Bran Stark. He's not the youngest? Oh, he's his little brother, yeah. Wait, what's his name? He's not here? Let's just go with Bran. So Bran Stark. So let's remove him. So for deleting, what we have is similar. Delete from fellows where first name equal Bran. Delete from fellows where first name equal Bran. Oh, I changed. So the second fellow is now Bran Stark. I thought there was somebody called Ben for some reason. Ben Stark. There is? Oh. Wait, that's like Ned. Cool. So just so that we see the result, let's see table without Bran. Let's select star from fellows. Just so that we see if it really removed Bran. Oh, that's a good question. This will be case sensitive. If I put all capital brand, it's not gonna find it. So we can think of, strings are case sensitive, but SQL keywords are not. Cool. So let's give it a run. PSQL-F, seed SQL. Oh, this is too much data, but if I open this up, we see that brand is no longer there. If we're deleting brand with this. Yes. How do you delete all? What do you think? You mean remove all the rows? Mm-hmm. No. Oh, you could drop the table, but I don't think you want to do that. Nope. Well, actually, yes, that's one option. You could use a wildcard here that will match any character. What if I remove this? The where? Yes. Just like in the update, we need a where. Mm-hmm. Only for insert, we don't need a where. For updating, deleting, and selecting, or getting, whatever you want to call that, you will need a where. Well, you don't need it. Most of the time you will, since you don't want to just display the whole table, or you don't want to update the whole table, or you don't want to remove the whole table. Yes? Mm-hmm.
Brand will remain number 2.
That's correct. Yes. Mm-hmm. What do you think will happen if I change this to last name Stark? Both of them are going to be deleted. So you can think of Postgres going down this table, checking every single row for this match. Yep. I'm not sure 100%, but I think I do know that, for instance, when you're checking something that is not a primary key, when you're getting something that is not by the primary key, there is, the database has to check every single record. So I think we could speak of n, where n is the number of rows that the table has. If you're accessing something that is not by the primary key, or by an index property that we're not going to get to see, but you could look that up. The primary keys are sort of kept in a hash table-like manner, where if you have the primary key, you have access to it really quickly. So if you say, I want the fellow with ID 200, it's going to be really quick. Yeah. So, cool. So that's all. This is sort of the fundamentals that you will need for the lab, updating, deleting, and insert. Make sure to check out so in the lab here, I linked all the way at the bottom these SQL Bowl tutorials that explain a little bit more detail what we just did here for inserting rows, updating rows, and deleting them. Yesterday we saw how to create tables, and I think that should be it for all you need. So yeah, so there is V1, which is what we expect all of you to complete, the V1, and the V2 is the bonus. You don't have to do it. You are encouraged if you have the time. Cool. So questions, final questions before we get to work. I'm gonna be here. You can ask questions, etc. Cool. Let's then jump into it. Yes. Yep. Okay. I'll be there in a